Alright, I am behind in grading this exam, so I thought I would do a little video tutorial so that you could use this. Alright, so here we have some data. We're asked to find R's and M's. To find R, we use the y2 over y1 to this power 1 over x2 minus x1. So if I go through and do some of these things, so if your calculator has parentheses, and it's nice to use those, so for this one, let's just, if we're not sure, then it's good to, alright, so then I'd use 368 divided by 359, and then to the power of, that's the caret, parentheses, 1 divided by, the difference is 5 years, so I'll just put 5 in there. And then enter, and I get a number, 1.004. I should round, so there's 1.005. And then the next one, parentheses 378 divided by 368 to the power of, and again the difference is 5, so I'll do 1 divided by 5. And then I get 1.005. And I'll pause and do the other two. So if we're keeping to 3 decimal places and rounding, that's the rest of the R's. And then to find the average, I have to add them all up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'll do that now. Alright, so this would be 1.004, keeping the 3rd decimal place and rounding. So to find B, the idea is that we use this average R because this particular B corresponds to the R. We're finding an exponential model. So we're referring to this equation. We have an average R, so what we have is y equals B 1.004x. And so we're going to plug in each xy to find a B. So, this pair goes to that B, that pair to that one, this pair right here, and that pair. So, for example, if I were to plug in one of them, I'd have 368 equals B 1.004 to the 40th power. So I could do that, right? I could type in 1.004 raised to the 40th and get a number, and then I'll have a little equation to solve, and this is fine too. We're keeping B to 0 decimal places, so it's not going to really matter. So then 368 divided by 1.17 is going to be equal to B. We can streamline this a little bit, so that's 314, but we're rounding, so I'll say 315. If you think about it, this expression here, for every x, we're going to end up with a number. B times a number, B times a number. So you can solve for this. You can say, well, y divided by 1.004 to the x equals B. Every time we're going to be dividing by whatever this thing is. Up here, it was the 1.17. So this is a little shorter. Let me show you. So now, if I take my y, 378, and divide by, use some parentheses, 1.004 to the power of 45, whoops, I need to delete that parenthesis and go down here. Then it gives me a number right away. If I'm rounding, that's 316. And I can do this again, so 387 divided by my average R value to the power of 50. Whoops. And just in one fell swoop, that's 317. Then let's just do the last one together while we're here. Power of 55. And that's 320. Then to find the average, I just add all these up and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I've got my y value. It's 314, keeping 0 decimal places. So then C is really straightforward. I know my B. I know my R. And so y and x are the variables. Now interpreting these things, so if R is 1.004, then this represents, you'd write full sentences, so I'm not going to do that because I'm trying to save time. But this represents a 0.04% increase. Multiplying R by 100 gives you 100.4%. That means that every year you have 100.4% of what you had the previous year. So you have 0.4% more. So increase in CO2 concentration per year. Again, you would say this in a sentence. And then B, so B is the value of the model at 1959, which would represent sort of the average CO2 concentration of that year. And then making a prediction. So the prediction would be, well, we take our model. Now, we have to know how many years this is since 1959. So we have 2,100 minus 1959. Well, all right, there's going to be 41 years until 2000. So this is 141 years. So we take our model, 314. There's our R to the 141, and we just see what we get. So 314, 1.004 to the power of 141, and this gives 551, whatever you can. I didn't give it a requirement. And this would be ppm, parts per million. So that's the prediction for 2100. All right, so in this problem, so the previous problems concerned just developing an exponential model. Here I give you a linear model and I ask you to decide between them. This involves the M and R test, right? This is the max versus min over the average. Well, we already have the average for R. We'll need to find the max and the min. I give you the max and min for M. So the max is 2.24, the min is 0.73. The average is right here. If you think about the work we've done in class, the average M becomes the slope of your best fit line. So we can do this one right away. So this is 2.24 minus 0.73 divided by 1.51, and I get 1. Which represents 100%, meaning that the slopes are spread out 100% around the average. Now, for the max and min R, let's go back to the first side. The min maybe 0.003, the max up to 6. So 1.006 minus 1.003. So let's compute that. 0.006 minus 0.003 divided by 0.004. That gives me 0.0029, etc. So the R is the better choice. And you would write something like the R is the better choice because the variation of the R's is less. They're closer to the average. And then comparing predictions, we already have one prediction. For the exponential, we just did that one. That's the 551. And then for the linear model, we just have to plug in the 141 years, since t represents time since 1959. So let's plug in what this is. So that's 522. So in terms of compare, you should say something quantitative. There's a couple things you could say. You could say 551 minus 522. So 551 minus 522. You could say, well, this is 29 ppm more. You could compare via division, which we did in a number of homeworks. The ratio of 551 to 522 is 1.055 repeating. So the top is 5% greater. 551 is 5.5% greater. Some sort of quantitative comparison, not just that one's bigger, but maybe a little bit more. Now in the second problem here, we have an equation, an exponential equation describing an account. A is in thousands of dollars, T is months since January. So some things, all right? The y-intercept, this is 11.8, and it's 11.8 thousands, or $11,800, and this would be the initial amount in January of 2018. The growth factor or decay factor's value, well, that would be 1.054, and then separately the interpretation, this would be 5.4% growth per month, since T represents months. So again, the way to think about R is that this represents 105.4% of what you had the previous month. So if every month you have 105.4% of what you used to have, you have 5.4% more. And then how much money is left in the account by this time next year? So it really just depends on how you answer this. I mean, if a bunch of you asked what this time meant, so if you wrote out that you used January, I'd give you that. If you wrote out that you used April, I'd give you that. This would be 12 months. This would be, say, 16 months or 15 months if you're going to April 1st. So some possible answers, 11.8, 1.054 to the 12th. So 11.8 times 1.054 to the 12th would give 22.18, so 22,000. And if we did 11.8 times 1.054 to the 16, say, that'd be 27.3 thousand. So something like that. I think I'll stop there, and I'll do a part 2 video on the third page.